Good morning, everyone, on our next lecture on the course of research. Research on safety and comfort of means of transport. And today we will talk about the research on comfort. Last time we talked about the research on safety. And we will use the innovation method based on analysis of vibrations. The most important topic when we are talking about the comfort in means of transport is probably the propagation of vibration into the human body. That is how it will be the most important issue when we'll consider the research on comfort in means of transport. Of course, we've got many different types of comfort when we are considering the means of transport, starting from vibrations, but also the noise comfort. It is extremely important, the acoustic comfort, also the thermal comfort, and also the sitting position comfort. So these are probably the most important four factors when we are talking about the comfort analysis and the research on comfort. But today we'll focus just on the analysis of vibration propagation into the human body. So the most important question when we talk about innovation method of research on comfort is to how analyze a vibration propagation into the human body. So we can consider the passenger or driver in a vehicle, for example, as the person who is sitting, which is sitting on the seat, of course, and we've got few points, contact points, when the vibrations are propagated into the human body. So first is the dash panel, yes. So by the contact with feet, we are transferring the general vibration into the human body. Second one is the seat, when we are transferring by the lower lumbar spine, also general vibration into the human body. But also we've got the transfer of vibration as the hand vibrations, transfer by the hands, and it is contact with the wheel, and by the steering wheel system it is also the transmission system of the vibration into the human body. But when considering the comfort factors, the most important are the general vibrations, which are transferred by the seat or by the floor panel. So when we are talking about the steering system and hand vibration, it is more important when we will consider the safety. So I would like to present you my own research which were conducted on this issue. So let's go through the presentation. So what is the motivation when we are talking about the vibration propagation in terms of comfort but also the safety? We can consider whole transportation system as the generator of different kind of vibrations but also noises. So we can consider the passenger car, for example, and all the vibrations generate inside the vehicles, which are affecting the passenger or driver inside, but also as the generator of vibrations of outside vibrations, yes, which are affecting the infrastructure, buildings, or even the passengers, not passengers, pedestrians, or other people outside of the vehicle. So it is the one. So this you can see the propagation into the structure. This is the propagation by the air, which will be considering as the noises. It is the different example when we are talking about the heavy vehicles, including the bus, but we've got also the one type of propagation into the structure, and all the results of the propagation into the structure will be resulting as vibrations. But we've got also the air propagation by the air, and will be resulting in noise. So everything's what is important, it is to understand the idea of propagation of waves into the structure, into the earth, which are generated by the transportation system and which can affecting people, all infrastructure or buildings outside of the transportation system. So it is the motivation. So vehicle-induced vibration propagation to the human body. The overall concept was also presented on the previous lecture. So it can be considered that it is the transfer function starting from the road roughness, yes, surface, into the tires, which are the first element of the damping system, then the structure and suspension system of the vehicle, and then the subjective perception of the passenger inside. So it is the special area in the field of vibration research in the transport system where drivers and passengers are exposed to various types of vibrations, because we are talking about different kinds of vibrations, which of course depending on the severity and frequency affecting the comfort of traveler and also indirectly on a safety. So we are not just talking about the comfort, but also indirectly we are talking about affecting on the safety. So vibrations affecting human can be caused by multiple sources. So second stage of investigation after understanding all transmission of the vibrations into the human body, we can consider what is the vibrations directly propagate into the human body. So first of all, we have to consider different directions of the vibrations, because we are more sensitivity on different direction of the vibration. So it is also important to research in different axes. Yes, so we've got the general vibrations to the whole body, yes, by the feet and by the lower spine, or the local vibrations which are transferred by the steering wheel. Yes, so we've got two types of the vibrations when considering the comfort. First is hand-arm vibrations, and second is whole body vibrations. It is the general vibrations, it is the local vibrations. So vibrations transfer from the road to the occupants can be illustrated as transmission by multi-filter elements. So this is how you can consider those systems. The excitation is given by the wheel movement caused by the road roughness. First, filtering vibrations occurs as a result of stiffness and damping properties of tires. Yes, so it is the first element. Second and third will be results of stiffness of damping properties of the suspensions in car body, and the last filter can be considered as biodynamics properties of human body. So vibration propagation into the vehicle structure, because we would like to focus on this stage. So these are the results of real research on a real object. So it was the excitation which was forced on each wheel of the vehicle. So here you can see the structure, the spectrum structure, the frequency structure of the excitation. So you can see that we've got the increase of the frequency up to the 21 hertz. Yes, then we've got the constant frequency, and next is everything is the next harmonics of the constant frequency. So we've got test system which are going through the resonance of sprung masses and unsprung masses. What you can see here, it is the unsprung masses results. Yes, so the first stage of analysis, the first transmission and absorption of the vibration is when we register the vibrations on the suspension arm. So when we are registering the vibration on suspension arm, we can consider that the only element which already absorbed some vibrations was the tire. Yes, because we are on unsprung elements of the suspension. So you can compare the volume of the vibrations just by the filtering the vibration by the tire. So you can see that the maximum value here was about the 9 meter per secunda square. Here we've got 5. So it is what the volume of energy which were absorbed by the tire. But from the second point of view, you can clearly see that the resonance of unsprung masses was much higher than in the first excitation plate, and it is results of the resonance of unsprung masses, because we are under unsprung mass, which is the suspensioner. So you can clearly see that it is the phenomena of resonance which is not good for us. So if we will transfer the vibrations to the passengers just by using the tire system, you can expect that the unsprung mass resonance will be huge factor to the comfort, but also to the safety. So next step of investigation is to research at the same time the vibrations on the upper mounting of shock absorber, which is the first point of the sprung masses. It is after working of a shock absorber. So you can see how much difference are structure of the vibrations when we are checking the vibrations after operation of shock absorber. So we minimize the resonance phenomena much lower. So it is huge impact of the suspension system in terms of safety, but also the comfort. But let's check how the vibration looks on the floor panel, because by the floor panel and by the contact with the feet and by the transfer to the seat, it is the volume of vibration which are affecting the human. So here you can see the vibrations under the driver feet. It is under the front passenger feet, it is under left rear passenger feet, and it is under rear right passenger feet. So please check the amplitude size, because scale, because we are talking about 0.2 volume, and here we started with close to 10. So we did absorb a lot of vibrations which will cause the discomfort effect. Okay, so next is comparison of vibration into the vehicle structure. So if we will compare the vibrations, the blue one, it is the vibrations of the excitation. The green one is on the arm of the vibration. We can see clearly the places when the car body, which is the upper mounting of suspension, and arm suspensions, these are the results. The difference in the amplitude of these signals shows us how efficient shock absorber is working. Also, the same comparison can be done on the floor panel, and you can see what are the different in the structure of vibrations for the different locations of sensors. What is shows us? It shows us that the structure of the vibrations affecting of the human in the passenger's car are not the same in each location. That is how maybe we should think about the different solutions for different location in the vehicle structure. So it would be the first conclusion, interesting conclusion. So the next step was to consider what are the vibrations transfer into the human body. So we are not talking about the transversion, just vibrations on the contact area, which are the feet or the lower lumbar spine. We are talking about the transfer of the vibration into the human body. So I designed and we did prepare the research stand. The research stand is very easy. We've got the table with the excitation, yes, we've got the seat, and we've got all mechanisms which shows us to control frequency and amplitude of excitation of vibration into the passenger or into the person sitting on the seat over here. So here you can see the whole experiment. It is myself. So we've got the excitation plate, we've got the seat over here, we've got the also a few elements which are important for the other types of study. We've got the computer, we've got the frequency device which control the frequency of the excitation, we've got the sensors placement in different locations. So it is the idea of research which show us what are the size and structure of the vibrations which are transferred from the feet or from the lumbar spine into the human body. So it was the overall idea of the research. So what was the location of the sensor? The location of the sensors also should shows us the path of transmission. So we started from the registering the vibration on the excitation. So it is the floor panel, we can understand. You can think like this. The first stage was to register the vibrations on the knee. We've got the sensors for each direction. Yes, it is what I mentioned, that it is important to consider the direction of the vibration also. The next was the lumbar spine, which is on the sit position. The next one was chest. Yes, so it is how we indeed measure the vibration on the test, and it is me also. And the last one was the head. We've got different resonance for the head, for the chest, for the knee, for the lumbar spine. So it is how we should conduct the research. Okay, so what was the results? So first, starting from analysis of waveforms of vibrations. So here you can see the vibrations register when the excitation was on frequency of 1 Hertz. So we are talking about the frequency close to resonance of sprung masses. Here we've got the x-axis, y-axis, and y and z-axis. Yes, it is the excitation. It is the knee vibration. So you can see what is the volume of vibrations which were absorbed by my leg. Yes, starting from feet into the knee. Next one is the vibrations of the lumbar spine. So here you can see totally different shapes of the waveforms. Here are the vibrations on the chest. So it is next point of the transfer. And the last one was vibrations in the free direction register on the head. So only if we are able to analyze the vibrations in different locations of sensor on the human body, we are able to analyze according to the resonance frequencies for the different organs in the human body. And this was 1 Hertz, which is correspond to the close to sprung masses resonance. The second is 10 Hertz, so it is probably the frequency which should be close to the resonance of the unsprung mass resonance, which is even more important to the safety than the comfort. The first one in the 1 Hertz is close to the comfort issues. So we've got again the excitation plate vibrations, the knee vibrations, the lumbar spine vibrations, the chest vibrations, and the head vibrations. So it is also what we can expect when we will have the frequencies correspond to close to the bands of resonance and unsprung masses. So it is much more important factor. And the next results which I would like to show you, it is propagation into the human body, and which did choose the next frequency, which is 3 Hertz. So it is, we can say, the upper volume of the frequency band correspond to the sprung mass resonance, which is also important to the comfort. So it is the excitation plate, the knee. I'm sorry, it is to the head directly. So it is excitation and propagation into the head. So you can compare the shape and volume of the vibrations. Here, if we will consider the 15 hertz, so you can see that there is the transfer. It is almost directly, so it is hard to find the differences. But if we will consider the y-axis and z-axis, you can see that it is twice less here on the head than on the excitation plate. But on the z-axis, which is the vertical vibrations, we've got 10 times less, because it is 15 on the excitation plate and just 5 on the Z position in head position. And the results for the extremely high frequency, when we are considering affecting on human body, which is 30 hertz, you can see what are the differences between the excitation and head vibrations. So here you can see, but it is extremely high frequency when we are considering the transfer into the human body. Okay, so if we will compare the floor panel vibration into the head, on one chart we can see the 3 Hz, 15 Hz and 30 Hz, and you can see the blue one is the floor panel vibration, and the green one is the head vibration. So for the 3 Hz, which is important frequency when we are considering the comfort factor, because it is correspond to the resonance of sprung masses, we can say that transfer is almost 1-to-1, which is not good for us, but it is a result of the resonance. Yes, we will consider the 15 Hz, which is correspond to the unsprung mass resonance, which is most important to the comfort. We can assume that it is 0.9, yes, transfer factor. But if we'll consider the highest frequency, which is 30 Hz, the transfer factor probably here would be about the 0.3. So it is how it works like. The same situation is when we'll consider the y direction, and the same if we'll consider the vertical vibrations, z-axis. We've got the same situation over here. So it is another example how we can analyze the comfort based on the different location. What is also important, it is not just about the volume of vibrations, about the amplitude of vibrations, but also to analyze the structure, the dynamical structure of vibration, which is the frequencies covered in the vibration. So it is how we can use the fast Fourier transformation to analyze the most important components of the vibrations. On the left, you can see the excitation plate. So it is what vibrations are in the contact area between the feet and the floor panel plate. It is for 1 Hz. Yes, it is the vibration on the leg, which is on the knee. You can see that we almost filtered all highest frequency than 40 Hz. So next one is vibration in the lumbar spine. You can see that we did filter vibrations up to 20 Hz. There is the chest vibrations. Yes, so you can see that right now some new component is showing up. Yes, based to this component on the input, but according to the resonance frequencies of the chest, it is the most difficult area, and also the head vibrations. So it is the example how we can analyze which components of the vibrations is transferred into the human body, and which components is close to the resonance of the organs in the human body. So it shows you directly the possibilities of designing the absorption system to hide the components, to minimize the components which are close to resonance of the organs, which is extremely more important when we are talking about the vibration comfort in the vehicles. So here is another example on the 10 Hz, which is the unsprung mass resonance. It is the components of the excitation plate. It is the component of the knee vibrations. It is the FFT of the lumbar spine vibrations. But look at the volume of the amplitude, so it is a little bit less. This is the frequency spectrum of the chest vibrations, and this is the frequency spectrum of the head vibration. So always check on the scale also when we are talking about the amplitude and the components, and you can decide and design the device which will be more efficient when we are considering the minimalization of the vibrations. Okay, so if we'll compare the value of the amplitude in chosen frequency for the excitation, you can compare the analysis of the values. Yes, so we've got the knee, lumbar spine, chest, and head. And for all three directions, you can consider what are the most, we can say, most difficult values when we are talking about the dominant frequencies. So this analysis should be always correspond and analyzed by the resonance frequency of the organs in our human body. For example, if I will try to increase the comfort of visibility, I should consider the A-ball resonance, which is starting from 20 to 90 Hz. So I should consider those values, especially when we are talking about the head. If I am talking about the chest, which is the of course location of our heart, and is important to the comfort and safety of the comfort, I am talking about the 50-100 Hz in the chest. So this I will analyze those value. If I will talking about the legs, I can analyze the system signals register on the knee. So it is what is called the first stage of analysis of the transfer of the vibration to the human body. The next step is to analyze how it's covered with the frequency, resonance frequency of the organs, and then how to design the devices which helps me to minimize the value of frequency transfer into the human organs according to the resonance frequency. So it is the overall idea. According to more advanced analysis, we can use also the time frequency analysis. I did present you last time the overall understanding of the time frequency analysis, including short time Fourier transformation, Velvet transformation, and Wigner-Wien distribution. So these are results of such investigations. So here you can consider the transport time frequency analysis, time frequency representation of the signals of the sitting positions, for example. Yes, for the excitation plate, it is vibration of the head, so you can control the structure of the vibration. Another example here of time frequency representation for the head, but for the different vibrations, it is for the frequency analysis, frequency of excitation about 30 Hz. So here you can see on the 20 Hz, I'm sorry. So here you can see, and this you can see the structure of the vibrations as the time frequency representation of the vibrations register on the head. So based on the analysis of the vibrations, it is good idea to set up some estimators which can be measures of the comfort or of the safety when considering the transfer into the human body. So first, most fundamental factor and estimator which can be used, it is the root mean square as the quantity value. The second one is my own estimator, which covers the information in the frequency structure of the vibration. So it is more correspond to the analysis also on the frequency estimator. So here you can see some results of those two factors, which is the resulting of comparisons between the RMS values and frequency values. Yes, so here is the frequency of the excitation, and here are the values of RMS or frequency estimator. So this clearly is visible what is the influence of the frequency on those estimators. So it is values for the knee in the x-axis, it is value for the knee in the z-axis, and it is some exemplar of values of the head in the x-axis. So this can be considered if I will set up some threshold value here, so threshold level, how to also analyze the comfort of the vibration. Another example is based on the one of the most fundamental estimator when we are talking about the vibrations measure. So it is the value which compares the root squid meters in all three directions, but when we are talking about the horizontal vibrations, we are multiplying the values by 1.4, and when we are talking about the vertical vibrations, we are talking about the non-multiplicatory value. So it is recommend estimator by the standards, vibration standard, exposure to vibration standard, and this is how the results looks when we will compare, calculate this value for the vibrations register on the knee. So these are the values on the chest and on the head. So you can see that if we are considering the overall standard estimators of the vibrations exposure, it is important to choose what vibrations I am analyzing. It is if it is the vibrations of knees or chest or head, because the values, as you can see, are totally different. So this was just overall presentation which shows you what are the possibilities, huge possibilities of applying the vibroacoustics method, vibrations research, into the research on comfort in the means of transport, and it also shows what are the profits of such approach, how deeply we can analyze the comfort, and how easily we can use this knowledge for the designing of the new system when we are talking about the comfort in the means of transport. So I think that it is huge possibilities and huge future in front of vibration research applied for the comfort analysis of comforts in mean of transport. So I think that it is the most important conclusion of this presentation. So I would like to thank you for your attention, and I hope that we will see in very close time. So thank you very much.